Hello students, welcome to online lecture series of discrete mathematics. So in last session we have studied what is this permutation and combination. So now for the today's session we will see what is probability. So the word probability means the chance or a possibility. So this probability means the chance of occurring of the particular event. It is generally possible to predict the future of an event quantitatively with a certain probability of being correct. The probability is used in cases where the outcomes of trial is uncertain. So the definition of probability: the probability of happening an event A is denoted by the probability of A, that is P of A, is defined as the number of cases favorable to A divided by a number of possible outcomes. So means here number of favorable outcomes divided by the all the possible outcomes is nothing but the probability of A. So if an event can happen in m ways and fails to occur in n ways, and m plus n ways is equally likely to occur, then probability of happening of event A is given by. So here if you have to find out the happening of event A, right? So event A, in that event can happen in m ways and event fails to occur in n ways, right? So here the probability of happening of event A is given by. So we know the definition. As per definition of probability, there's a number of cases, that is favorable outcomes of A, is divided by the number of possible outcomes. So here number of possible outcomes are m plus n, and favorable outcomes for event A is n. So probability of A is equal to m upon, right, m plus n. And the probability of non-happening of A is, that is P of A bar, is equal to, right? So here number of favorable outcomes for probability of non-happening of A, right, is n, and all the possible outcomes are m plus n. So probability of non-happening of A is probability of A bar is equal to, is P of A bar is equal to n upon m plus n. So here you have to note here some points are related with this probability. The probability of the first point, the probability of an event which is certain to occur is 1. Second, the probability of event which is impossible to 0. Third, if the probability of happening of event A, that is probability of A or P of A, and that of not happening is probability of A, that is P of A bar. Here is P of A bar. P of A bar. Then the P of A plus P of A bar is equal to 1. Is equal to 1. So 0 is less than or equal to probability of A is less than or equal to 1. So here you have to remember just whatever happening of event A plus not happening of event that A, that is probability of that event, is always equal to 1. Next, some important terms related to the probability. So first is trial and event. What is this trial and event? The performance of an experiment is called a trial, and set of its outcome is termed as an event. So for example, tossing a coin and getting a head is a trial. Then event is whatever outcomes, right? So getting a head, right? So getting head is your outcome. So event is, so there is HT, TH, HH, right? Second, random experiment. It is an experiment in which all the possible outcomes of the experiment are known in advance, but the exact outcomes of any specific performance are not known in advance. For example, tossing a coin, then rolling a die, again driving a card from pack of 52 cards, or sorry, drawing a card from pack of 52 cards, or drawing a ball from a bag. So here you have to remember basic here. Whenever we consider probability, right? So probability means the possibility. So your best example for this probability is tossing a coin. Whenever we tossing a coin, so either head appears or a tail appears, right? So possibility are two, right? Head or tail. Whenever we consider what is the possibility or probability of getting a head, then probability is the chances of getting a head is 50-50 chances. Means probability of head is 1/2. Probability of tail is again, whenever you consider 50-50 chance, probability of tail is again 1/2. So just you have to remember here, probability means a possibility, right? That possible outcomes. Next, the outcome. The result of the random experiment is called an outcome. So tossing a coin is an experiment and getting a head is called an outcome. So whatever the result here, so getting a head is your outcome, right? Second, rolling a die and getting a 6 is an outcome. Then sample space. Sample space means a set of all the possible outcomes of an experiment. It's called as a sample space, and it is denoted by generally a S, that is capital S. So when a die is thrown, the sample space is, so we know the die or dice is containing a number 1, 2, 3, 4, 5, 6. So for this, when a die is thrown, the sample space S is equal to 1, 2, 3, 4, 5, 6, right? So it consists of 6 outcomes. There is 1, 2, 3, 4, 5, 6. Either one of the either any one result may be come here, either 1 or 2 or 3 or 4 or 5 or 6 when a die is thrown. So complement of event, the set of all outcomes which are a sample space, right, but not an event, is called as a complement of an event. Next, impossible event, an event which will be never be happen. Example, tossing a double-headed coins and getting a tails is an impossible event. Second example, rolling a die and getting a number, right, greater than 10 is an impossible outcome, right? So we know that rolling a die, on dice there are only 1, 2, 3, 4, 5, 6 numbers are there. So getting a number greater than 10 is always a impossible outcomes. 7, the result. Next point is sure or certain outcomes. So this is an outcome which will be definitely be happen. Means tossing a double-headed coins and getting heads only. Getting heads only. Right? So this is a certain outcome. Example 2. So rolling a die and getting a number is less than 6. So this is a sure outcome. Right? So whenever rolling a die, definitely less than 6 number may be come. Right? So next, possible outcomes. And outcomes which is possible to occur is called possible outcomes. So tossing a fair coin and getting a head on it. Example 2, rolling a die, getting an odd number. Right? This is a possibility, getting an odd number. So equally like events. Events are said to be equally like if one of them cannot be expected to occur in a preference to others. In other words, it means each outcome is likely to occur in other outcomes. Example, when a die is thrown, all 6 faces, that is 1, 2, 3, 4, 5, and 6, are equally likely to occur. Next, mutually exclusive or disjoint event. The events are called mutually exclusive if they cannot occur simultaneously. Suppose a card is thrown from a pack of cards, then even getting a jack and getting a king are mutually exclusive because they cannot occur simultaneously. Then exhaustive events. The total number of all possible outcomes of an experiment is called as exhaustive events. So in the tossing of a coin, either head or tail may turn up. Therefore, there are 2 possible outcomes. Hence, there are 2 exhaustive events in a tossing of a coin. Independent events. Let A and B are said to be independent if occurrence of any one event does not affect the occurrence of other event. That is the probability of A intersection B is equal to probability of A into probability of B. For example, a coin is tossed thrice and all 8 outcomes are equally like. So A with the event that is first throw results in A, and B with the event that last throw results in tails. That is prove that A and B are independent. So for here sample space for this example, right? So this is a sample space containing 8 elements, right? Containing 8 elements. That is HHH, HHT, HTH, THH, TTT, TTH, THT, HTT, right? So and A with the event, right? Is first throw results in A. So for this in sample space, how many is container that first is your head? So whenever you're tossing a coin thrice, so here HHH, HHT, HTH, and HTT. Here containing a the first row results in head. Then B, then HHT, TTT, THT, and HTT. Here last row results in tail. So A intersection B. So A intersection B is whatever common is there is HHT and HTT. So what is the probability of A? That is the first row results in heads. So what is that probability? So here favorable outcomes are 4 for the event A, right? And sample space, that is all possible outcomes are 8. So probability of A is equal to 4 by 8, that is 1 by 2. Same probability of B is equal to 4 by 8 is equal to 1 by 2. So probability of this A intersection B equal to 1 by 2 into 1 by 2, that is 1 by 4. So in next lecture, we will see the next part.